Isomerism in alcohols. This is first year topic. This is not new topic, right? How we will get the question? Isomerism first year chapter. How it will come in the second year? Just basic level questions only will come, not in depth. That basic level questions are. See, you will get one molecular formula. For that molecular formula, how many isomers are possible? For example, C4H10O. C4H10O. This is alcohol. How many structural isomers are possible for this? How many structural isomers? You know structural isomers? 11 or 7? 7, yes. 7 structural isomers are possible. Yes, correct answer. See, how to draw all the structural isomers. 4 carbon atoms are there. So first write like this: 1, 2, 3, 4. 4 carbons and put OH here. OH. Now complete the valency. 4 bonds should be present around carbon. CH3, CH2, CH2, OH. Okay. This is first one. And what is its name? 1-butanol. OH group is at the first carbon, so 1-butanol. 1-butanol. You can place OH at the second position also. If 1-butanol is possible, then 2-butanol also possible or not. So second isomer, CH3, CH2, CHOH. Sorry. 2-butanol. This is second. 1-butanol, 2-butanol. Next. Third possibility. See, this is 1 degree alcohol. This is 2 degree alcohol. We can write 3 degree also, like that. Based on the degree also, we can write another one. 1 degree or not? Why it is 1 degree? OH is connected to 1 degree carbon. This is 2 degree because OH is connected to 2 degree. Middle carbon is connected to 2 carbons. So you can write third one 3 degree. Tertiary butyl alcohol, CH3. 3, 1, 2, 3. For this formula 3, up to now 3 are over. Next. Fourth one, see, whenever you get a straight chain with 4 carbons, you can rearrange that. Means, I am keeping this carbon as it is, this CH2OH as it is, and I am rearranging these 3. This is hit and trial only. Hit and trial means just you have to find or you have to search for all the possibilities. These three carbons are there. Now we are rearranging. These 3 are in the straight chain format. Now you are taking some branches. What is its name? 1, 2, 3. 2-methyl propanol. This is one possibility. So how many over? 4 are over. So 1-butanol, 2-butanol, 2-methyl propanol, tertiary butyl alcohol. Any other possibility? You think 4 are over, right? Any other possibility? Is there any? Sorry? No. Only alcohols. Is there any possibility? All combinations are over. Clear? Alcohols are functionally isomeric with ethers. So you have to check for ethers also. Alcohols are functionally isomeric with ethers. When alcohol is present, then check for ether also. So fifth one, CH3, CH2, ethers general formula ROR. This is one ether. Another ether is, see, this side 2 carbons are there. Send 1 carbon that side. Keep 1 carbon only on the left hand side. This is another possibility. Okay. 6. Next, 3 carbons are arranged in the straight chain format. Now arrange them as a substituents. Branch CH3O CH3. Why I am explaining this? In the second year also they will give the questions based on the isomerism in the weekend exams. How many structural isomers are possible? How many total isomers? Total means optical. We will do optical also after completing this structural. So total 7 are possible for this formula. 4 are alcohols and 3 are ethers. Total 7. 7 structural only. 7 structural only. If you get the question like this, how many total isomers are possible? How many total isomers? When you get the question about the total isomers, then you have to take a chiral center into consideration. Chiral center. Chiral center means the carbon which is surrounded by. What is a chiral center? The carbon which is surrounded by four different atoms or groups. See, in this chiral center is present or not? Not present. Here chiral center, yes. Star mark. Keep star mark for the chiral center. Methyl 1, OH is 1, this methyl is 1, and H. Total 4 groups or atoms are present. Chiral carbon. When you get chiral carbon, instead of taking 1, write 1 plus 1. 1 plus 1. If chiral center is formed, take 2 compounds there. Take 2 compounds because mirror imaging is possible, right? Or simply remember, if chiral center is formed, instead of writing 1 isomer, write 1 plus 1, 2 isomers. 2 isomers. So 1, 2, 3, you have to count like that. When only structural are asked, don't write 1 plus 1. And total isomers are asked, indicate chiral center and write 1 plus 1. So 1, 2, 3, 4, 5, 6, 7, 8 isomers, including optical also, right? So we may get questions on this calculation of number of isomers for the formula C4H10. Like any, not only C4H10, any other formula also. Okay, and this is completely hit and trial only, right? Next, in the second chapter, alcohols, ethers and phenols, or phenols, ethers. So I'll start ethers. Ethers is a small chapter, so we'll complete ethers, right? Next, the subtopic in the second lesson. In second lesson, we have alcohols, we have phenols, and we have ethers. Next subtopic, ethers. Ethers. Ethers general format ROR, where R is the alkyl group. Alkyl group like CH3, CH2, or cycloalkyl also, or even aryl groups also. Anything, or maybe anything. In first nomenclature. Tell me. Sorry. Alcohol was finished. Test also completed, no? Identification test. Completed alcohols. You are asking about finish of lesson, right? Completed or not? Alcohols. Alcohols was completed, but that is subtopic. In the second lesson, alcohol is one of the subtopic. Ethers is another subtopic, and phenols also another subtopic. If we finish phenols, then second lesson will be finished. But alcohols was over. Preparations, properties. See the nomenclature of ethers. Nomenclature of ethers. See the suffix for ethers. Suffix how ethers name will end. Alkoxy, alkoxyalkene. Alkoxyalkene. Ethers name present in this format. Alkoxyalkene. Alkoxy is given for the chain with less number of carbons. Less number of carbons. This word alkoxy word is given to the carbon chain with less number of carbons. Alkane word is given to the chain with more number of carbons. Chain with more number of carbons. Chain with more number of carbons. Let us see this example. We have two chains, the right side one chain and the left side one chain. In the right side chain only one carbon is present. One carbon is present. So if one carbon is present, what is the root word? What is the root word if one carbon is present? Meth, eth, prop. So methoxy, this part is a methoxy part. Methoxy, see. Alkoxy, less number of carbons. Methoxy. And here more carbons are there. Ethane. Ethane. Now arrange in this format. Methoxy, ethane. Methoxy, ethane. Give alkoxy word to the chain with less number of carbons. Give alkane word to the chain with more number of carbons. One carbon is present and the root word is meth, so methoxy. Here two carbons are present. Root word is eth, so ethane. You try this. Give the name for this. Two carbons are there. Root word is ethoxy. Ethoxy. Three carbons. Next alkane, propane. Ethoxy, propane. Ethoxy, propane. We have two important examples, very simple ethers, but important. See them. Shall we go to next page? So third example, very simple ether only this is. Say you can take any part as alkoxy because both are having same carbons. Right side one carbon is there, left side one carbon is there. So your wish. Methoxy, methane or methoxy, methane. Anything is correct. Methoxy, methane. Its a common name is very, very important. I am giving common name in the bracket. Dimethyl ether, dimethyl ether. Dimethyl ether. See its molecular formula. Write molecular formula also. What is its molecular formula? What is its molecular formula? C2H6O. C2H6O. Write molecular formula also. C2H6O. Another important example is there, similar to this. Diethyl ether or ethoxyethane. Ethoxyethane. Ethoxyethane or diethyl ether. Ethoxyethane, also called as the common name is important for this also. Diethyl ether. two sides ethyl group is present. Two sides ethyl group is present. Diethyl ether. Diethyl ether. Okay. Use star marks for this and write for molecular formula also C4 H10O. C4H10O. Mention molecular formula. Mention molecular formula. Next, another important example is there. Aromatic ether. It is called as methoxybenzene. Methoxybenzene is the IUPAC name. Tell me. Very good. Anisole. Anisole. This common name is important. Anisole. Anisole are also called as methoxybenzene. Benzene ring with OCH3 is called as anisole. Methoxybenzene. Ethoxybenzene. This is ethoxy. Phenetol is the common one. Methoxybenzene. It is a very small chapter. Ether shows which type of isomerism. This is about nomenclature. Next, isomerism in ethers. Isomerism in ethers. Isomerism in ethers. In ethers, we can see functional group isomerism and we can see metamerism, and we can see positional also. Positional isomerism. Optical also possible, but we won't give separately. Okay, we can create optical isomerism. First, functional group. Ethers are functionally isomeric with alcohols. First EFG. Ethers are functionally isomeric. With the alcohols. One example, C2H5, C2H6O. For this you can write alcohol and ether. CH3OCH3 ether, CH3CH2OH. See, both are having same molecular formula, C2H6O. Formula is C2H6O, here also formula is C2H6O only, but here functional group is ether, here functional group is alcohol. So when you wanted to write all the isomers, structural isomers for a formula which is having oxygen, single oxygen, so you can try for alcohols and ethers because both are functional isomers. After completing alcohols and write ethers, all ethers. With one oxygen, possibility is alcohol and ether. Even aldehyde ketone also. That is later, right? Next, keep second example, metamerism. Here, isomerism is just like a revision of basics only. Not we don't go into depth. Okay, in the first year isomerism, we discuss depth concepts. Here only introduction time. Questions also will come like that only in the second year. Metamerism. What is definition of metamerism? Ethers show metamers, unequal carbons. Very good. See, this is one side chain and this is one side chain. ROR. Here number of, let us consider number of carbons. Number of carbons are 1. Number of carbon atoms are 3. Number of carbon atoms are 3. This is one ether. This is one ether. I am taking another ether. Another ether. Number of carbons 2. This side number of carbons 2. Now 1 and 2 are called as metamers. First, see right hand side chain. In the first ether, in the right hand side, 1 carbon is present. In the second ether, in the right hand side, 2 carbons are there. Difference is there or not? Yes. Right side checking first. You have to check right side. Next, coming to the left side. In the first ether, in the left hand side, 3 carbons are present. In the second ether, in the left hand side, 2 carbons are present. So difference is there. So the compounds with the same molecular formula, even same functional group also same, but differ in the number of carbons in side chain. A simple definition: compounds with the same molecular formula but differ in the number of carbons in side chains. Having same molecular formula but different number of carbons in side chain are called as metamers. Along with ethers, ketones exhibit metamerism, secondary amines exhibit metamerism, esters can exhibit metamerism. In the first year, I given all that examples, but this is ethers especially, so we discuss examples of ethers only. Let us take one example. Only basic information will be given to you here. Do not go into depth. This is first ether, this is second ether. Right. 2 ethers are there. Check right hand side chain. Number of carbons are 2. Here number of carbons are 3. So difference is there. Yes, one side condition is satisfied. Now coming to left hand side. Here number of carbons are 2. Here number of carbons are 1. Condition is satisfied. So both are metamers. Right. Coming to the preparation methods. Preparations of ethers. Very small chapter and very easy chapter also. Okay, this is subtopic, not chapter, subtopic actually. In the second chapter, subtopic. See, preparation method. Preparation method. Roman number 1, from alkenes. Preparation from alkenes. Concentrated H2SO4. Alkenes when treated with concentrated sulfuric acid. Remember, how sulfuric acid will dissociate? H plus and HSO4 minus. H plus and HSO4 minus. Add these two. Okay. Add H plus to this carbon and HSO4 minus to this carbon. Dissociate sulfuric acid. H plus and HSO4 minus. Take the two and add. You know, I'll give the shortcut mechanisms only, right? When original mechanism is important, then only I'll give you original mechanism. just addition of H plus and HSO4 minus, bisulfate ion and H plus. CH3, CH2, here can I write like this, SO4H in the proper form, SO4 minus or SO4H. This is called ethylene hydrogen sulfate. Ethylene hydrogen sulfate. Ethylene hydrogen sulfate. First we get ethylene hydrogen sulfate. When it is treated with warm water or heating with water, warm H2, this SO4H will be removed, OH is added. See, this is another indirect method of preparation of alcohol also. In the first stage we get alcohol, from that we will get ether. This is this can be used for ethanol preparation also, right? Take ethylene, add H2SO4, you will get ethylene hydrogen sulfate, and add warm water. This total group will be removed and OH will be added. You can consider it as a step 1. In the step 1, we will get alcohol, not ether. You can write this ether like this: CH3, CH2, OH. Both are same only, right? Ethanol. In the first step, ethanol is formed. Right. In the second stage, you know this reaction. Next I am giving one reaction. You know that reaction easily. CH3, CH2, OH. How many of you prepared alcohol chapter? Alcohol chapter. ONA. I'll add one reagent here. I'll get ether. What is that reagent? Concentrated sulfuric acid at 140 degrees centigrade. Al2O3 at 250 degrees centigrade. Temperatures are very, very important. In this case, you will get the ether. Once check alcohols. Here also you will get ether. Once check alcohols. I have given the mechanism also. Mechanism like this. CH3, CH2, OH. Take another molecule, 2 molecules, and remove water from these 2. Remove H2O. CH3, CH2O, CH3. Join these two. After removing water, this part, here what is remaining? CH3, CH2O. Here CH2, CH3. Join these 2. You will get ether. This reaction is given already in the alcohols chapter. Once check the alcohols. Chemical properties. In the dehydration I given this. When we use 170 degrees centigrade, what will happen here? When we use 170 degrees centigrade, what will happen? What we will get? Alkene is formed. When we use 350 here, alkene is formed. I think you are not reading. Why I told in advance? Remaining students are not the answers. I am saying organic paper will be tougher. I am not making you afraid, but I am telling the truth. For elite students especially, weekend organic will be very tough. If you practice 100 questions, some 1 or 2, 1 or 3 questions will be new to you. If you are in advance in the preparation, then only you will score in organic. Should be in advance, all of you. Next week, next coming exam, you have alcohol chapter also now. Sunday I will conduct the test. You prepare seriously, all of you. We are doing in advance organic chemistry. I won't stop. Okay, I will continue. I will complete in advance for you, organic track. This is first preparation method. Tell me. Normal Markovnikov's addition. Negative part adds to carbon with less number of hydrogens. Markovnikov's. Second preparation method, Roman number 2, from amines. Preparation from amines. Primary amine. This is primary amine, ethanamine, when treated with NaNO2 plus HCl at 0 to 5 degrees centigrade. 0 to 5 degrees centigrade. The total NH2 group will be replaced. NH2 group will be replaced and OH group will be substituted. Alcohol is formed. This reaction also used for the preparation of alcohol. See, I will give the trick and I will give the mechanism also. If you are interested, then learn the mechanism. Otherwise, remember directly. When we use NaNO2 HCl along with the primary amine at 0 to 5 degrees centigrade, remove NH2 and place OH. Whatever it may be the amine, but that should be a primary. For example, you can take propanamine also. Irrespective of the length of the chain, if you use this reagent, NH2 will be removed and OH will come. Propanol is formed. Okay. Whatever it may be the length, in place of NH2, write OH. This reaction can be used for the preparation of alcohol also. Now, but what is our aim? Our aim is to prepare ethers. This is stage 1. In stage 1, we are getting alcohol. In stage 1. In stage 2 or step 2, take this ethanol and follow the previous method. CH3, CH2OH, sulfuric acid, H2SO4. CH3, CH2OH at 170 degrees centigrade. Same reaction. Previously you wrote this 170 or 140. Sorry. 140 will give alkene. So you will get ether. The difficult thing is to remember this step. This is easy only. In alcohols also this scale. And this step only difficult. Clear? Remove NH2 place OH. So note down this. What is the role of NaNO HCl? It removes NH2 group and place OH. Remember this too. Okay. This is one preparation method from alkenes and from amines and from amines. In alkyl halides, you have one reaction, very important reaction. What is that reaction? In alkyl halides, one chemical property is there. Williamson's ether synthesis. Williamson's ether synthesis. Next preparation method, Williamson's ether synthesis. Williamson's ether synthesis. Especially ethers are prepared by this method. Sodium alkoxide, when treated with the alkyl halide, ether formation takes place. ROR dash. See the mechanism. Oxygen with the negative, sodium is having positive charge. X is the halogen, X is equal to chlorine, bromine, halogen. Halogen is having negative, this R is having positive. If one is negative means another one is positive only, na? Right. Now see, it is a type of SN2, backside attack, SN2 mechanism. Oxygen attacks are from the backside. At the time X will leave. Only O, see like this, R with O attacks from the backside. At the time X leaves. That X and this Na comes out as a byproduct, NaX. But don't bother about this, leave it byproduct. But how to write the product is important. Another simple trick is there. This is general mechanism, SN2 fashion, SN2 mechanism. Another trick, simple trick, write like this. Take first ether, write sodium at end, X, just write in the reverse order. A, B and B, both are same only, no? A, B and B. RX, XR, both are same. So write like this and remove sodium halide NaX minus NaX RO R dash, join these two, RO and R, join these two. We will get merging only, merge the remaining two units. This is Williamson's ether synthesis, already given in the alkyl halides chemical properties, very important reaction. And I given condition also. What is the condition for R dash? R dash should not equal to very good. See, you are revising Williamson's ether. This is over already with examples also. Okay, I'll give the conditions for R dash. R dash should not equal to vinyl group. R dash should not equal to aryl group. R dash should not equal to tertiary alkyl group.